Am I audible, sir?
Yes, madam, you are audible. What is your ID so that we can make you co-host?
Maybe I start counting.
What is written there in the which zone you are using?
Or maybe I do a deep breathing. So like,
Jolsna?
how does this help when you're on shift? Suppose
Jolsna?
Am I audible?
or maybe I should be getting attacked.
Jolsna, you are audible, ma, but where you, which is your ID? We have to make you co-host, do the presentation.
Not scared. He may be scared from inside.
Hello?
My ID.
Yeah, how do I find who you are? Which is the ID which you are talking from?
Come out and help
Sir,
the
my
team.
name is there, no?
No, I don't see the name. That's why I'm asking you.
Third is
One
empathy.
second, sir. Let me check.
Empathy is
Or is it saying admin? Is that the one yours?
Yes, sir.
Okay, I am making that admin one as co-host.
sympathy is
Now you would have received that. We have been made host. Has come?
I'm sorry, we lost it. I'm so sorry. It's all superficial. It doesn't have any action. But empathy is when you understand the
My ID I have not yet received, sir. Your passcode I have got. Participant ID 1292885, sir.
self-motivated.
You speak now. Let me see which one is getting activated.
It means they always push themselves.
Can I share my PPT now?
At time they're able to motivate. And because of that,
You have been made co-host, ma. That is what I am saying. You try sharing, it will come.
Yes, sir.
all right.
Is it visible, sir?
People they can eat.
Jolsna madam, it's visible now. You please go ahead and start run by yourself. Okay, we will
Okay,
all
sir.
be muted only.
Yeah,
Thank you.
thank you.
So it's very
Hello, good morning, everyone. Myself, Dr. Jolsna, lecturer, Wales School of Maritime Studies, Chennai. So today's session is about physics discussion or physics question paper discussion for IMUCET exam. So first of all, let me introduce the mark division of each subject. Your total marks will be 200. In that, English 40 marks, mathematics 50 marks, physics 50 marks, general aptitude 40, and chemistry 20 marks. From this itself, you can see that they have a 50% that is maximum mark for this is allotted to mathematics as well as physics. So it is like, you have to little bit concentrate on these two subjects to score good marks or good rank in your exam. Okay. Now, the major topics of the syllabus for IMUCT exam is first is the basic thing is that your +1 +2 portions you should be thorough, or else the basic theories whatever you have studied in those 2 years is the basic topics for this IMUCT exam. So before starting the session I need to tell that this exam is like, it is not like a level of JW or KEAM exam. It is very easy for an average student to crack the exam. Okay. And like provided you have to work a little bit towards the topics or concentrate on the theories basically. Okay. So the topics for IMUCT exam is first for the is laws of motion and work, energy and power. That is this thing I think you might have studied in +1 topics: properties of matter, electrostatics, current, electricity, magnetic effects of electric current, electromagnetic induction and AC, dual nature of radiation and atomic physics, nuclear physics, semiconductor. So these are the major topics you need to cover, or you need to be thorough with the for the IMUCT preparations. Okay. So the topics which I am going to discuss in this session is electrostatics, magnetic effects of electric current, electromagnetic induction and alternating current, dual nature of radiation, atomic physics, as well as nuclear physics. Okay. The first thing you need to concentrate for this is the equations related to each topics. Okay. So the equations, like in each topics you need to be thorough with that topic so that you can crack the questions easily. And later on I'll tell you the tips and tricks what you need to follow, how to crack a questions, how to tackle it, I will tell. Okay. Now for the electrostatics, yes. So for the electrostatics, we will just discuss about the major topics or theories which electrostatics. Okay. So first is charge. Charge we know that it is of positive as well as a negative charge. And the properties of charge. What do you mean by quantization? Quantization is nothing but, the word meaning quantization is you need to divide a linear thing into different types of packets. Okay. The same way the charge is quantized into different packets of energy. So the properties of the charge is, it is not in a linear way. It is like you need to like quantize means small packets you will divide it. Okay. So the first property of the charge is quantization, where each charge is q is equal to n times a, where n can be 0, 1, 2 and e will be the charge of an electron. And it is additive. Additive means you can summate it together, even if that is positive charge or negative charge, you can both summate it. And conservation, which whatever the system you are taking, the total charge of that particular isolated system will be always a constant. Okay. Now Coulomb's law, that is the very basic law which known as Coulomb's law, which you studied in electrostatics, as well as the same way you will study in magnetostatics also. Okay. So the mutual electrostatic force between Q1 and Q2, where Q1 and Q2 will be your charges. If this is separated, you suppose you are having two charges and it is separated by a distance, some distance r, which is given by a force of charge F will be. So the force between these two charges is represented as K Q1 Q2 R12 by R square, where R12 is nothing but your unit vector, and unit vector in the direction from Q2 as well as Q1. So for one or two charges, so you can quantize it, like it can start from one charge to nth charge also. Okay. So the charges present, you can summate it together, the force between these two charges. Now another one, electric field. Electric field is nothing but other region around that particular charge in which electrical effects can be observed. Suppose 2 or 3 charges is there in a system, so there will be a particular electrical effects in that particular space between that charge. That is known as your electric field, and electric field has its own existence and it is present even there is no charge to experience the electric force. What is electric field intensity? So electric field intensity is the equation, the basic equation, which is very important, equal to F by Q naught, where F is nothing but the force experienced by a test charge Q naught. It is a vector quantity. What do you mean by vector quantity? Anyone?
They have both the direction and
Yes,
magnitude.
so it has both direction as well as magnitude. Okay, so some points to note on this is nothing but electric lines extend away from positive to negative charge. That is electric field of lines that it will start from positive and then it will end to the negative charges, and electric field produces the force. So if a charge Q is placed in the electric field E, the force experienced is nothing but Q times the, that is charge into that electric field, and it is a superposition, which means you can add up each electric field. E is nothing but the summation. Again, this is a summation, E1 plus E2 plus E3 plus E4. Now electric field intensity due to the point charge, that is point charge E, is nothing but KQR by R square, where R is the distance from the point charge and R is the unit vector. So the difference between the electric field intensity, one thing you need to keep it is there. So the Coulomb's law, you can see that the force is depending upon the square of the distance, as well as here the electric field is depends also the square of the distances, which is very important. Now, so these are the various equations or the graph which is related. The graph is also important. Sometimes in questions or in objective type of questions, they can directly ask what is the graph of e to the distance or electric field intensity versus distance of a point charge or infinitely long charge and all. So that the graph, if you study thoroughly, means you can directly, without any doubt, you can click the answer. Okay, so the point charge, the basic formula is we known as, since it is one charge, so kq by r square, which is equal to kq by r cube. So q is the source charge which produces basically the charges, and r is nothing but the vector drawn from the source charge to the test point. And so the graph which is related to the point charge, which is the electric field intensity at y-axis, and r at x-axis, is nothing but the graph. You can see it's like an as the electric field intensity increases, as the distance increases, the electric field intensity will be decreases. So now infinitely long charge, for this one, as you can see, the charge direction which is moving apart from those two charges, your formula for this is infinitely long charges lambda by 2 pi epsilon naught r, which is equal to 2k lambda by r into r cap, where lambda is nothing but your linear charge density, r is the perpendicular distance from the point, from the line charge, perpendicular distance from the line charge, and r cap is nothing but the radian unit vector. As you can see that for the point charge and the infinitely long charge, the graph is the same. The shape of the graph is same, which means it is like the each, they both work as the same property. Okay, now uniformly charged ring, that is which is related to a circle. So your equation, direct equation for this is E equal to kq x by r square plus x square whole to the power 3 by 2, where q is the total charge of this particular ring, x is nothing but the distance of point on the axis from the center of the ring, electric field is always along the x-axis. As you can see that the graph between, yeah, so the graph between r by root 2 and e will be like, it is a Gaussian graph. What kind of graph is this? It is a Gaussian surface. Okay, so there will be a saturation, and at a point as the electric field increases, the radius increases, what happens? Your electric field intensity increases. At particular point it will get saturated, then after that what happens? It will gradually decreases. So these graphs are also very important. Now, for the infinitely large non-conducting sheet, your formula for this one is sigma by 2 epsilon 0 n cap, where sigma is nothing but surface charge density, n is unit normal vector, electric field intensity is independent of distance. So you can see that your see that it is constant, that is electric field intensity. Whatever the distance increases, you will have a particular constant electric field intensity there. Okay, as you can see here, so what we have to keep it in mind, for the point charge and infinitely long charge, your graph are same. Uniformly charged ring, it is a Gaussian surface, and for infinitely large non-conducting sheet, it is nothing but a constant charge. Now infinitely large charge conducting sheet, so sigma by epsilon 0, as you can see that, so these two graph are also same. Okay, so sigma is nothing but surface charge density, and uniformly charged hollow conducting or non-conducting sphere or solid conducting sphere. For three cases, your equation will be E equal to kq by mod r square, and your graph will be like this. Okay, now let me go to, like, you need to be thorough. These are the basic electrostatics equations, like in that particular topic. These all equations you need to be thorough. Okay, now let me have some questions here. Can you just solve it? If you are, like, work done to bring a unit positive charge from infinity to a point in an electric field is known as what?
Potential.
Electric potential, that is how much work you have done to bring a positive unit charge from infinity to that particular point in an electric field, nothing but your electrical potential. Okay, so these kind of questions they will ask in IMUCT. These are some questions which I picked from that IMUCT previous papers. So you can see that it is a direct questions. If you are, like, if you are very good in theory, means this one you can easily, you can tackle it. Just directly you can tackle the answer. Okay, now if VA and VB are the two potential of 2 points A and B, what will be the correlation between electric field and the potential difference between these 2 points? So the distance between the points is D and VA, that is potential at the point A is greater than potential at the point B. Okay, so from here you can see that they have given 2 points A and B, in which A will have a potential VA and B is having potential VB. Okay, they are just asking what is the relationship between electric field and potential difference between these points. It's a direct question. Just you need to see the, just you need to, like, be thorough with the theory. So the direction of electric field is always from point with a higher potential to a lower potential. That we can see, they have already given that exact hint here, like that they have given the distance is D and VA is greater than VB, which means the potential at point V is greater than potential at point B. Okay, so according to this, you can see that the direction of the electric field is always from a point with higher potential to a lower potential. Therefore, to bring a positive charge from B to A, the work done will be a negative work. So from here, so one of the trick you need to see here is, like, you need to check whether the, you need to analyze the options first. Think that, like, first, it is like an elimination method. First you check the options, just see what all things you can eliminate. Okay, so here they have given the potential is VA is greater than VB, so definitely there will be a chance that the difference between VA minus VB, so here they have given it is VB minus VA. Okay, so it is like all the three is eliminated, only VB minus VA. So your work is from where? Your work is from B to A. So your work done will be from potential difference will be VB minus VA, which is equal to ED. So this is like, one trick you can see. Just see or analyze the options first. See what you can eliminate from the options. Already they have given the work done is from B to A. So your difference should be from B to A only. So your, see, the other options all are from VA minus VB, VA minus VB, VA minus VB. Okay, so from this options itself, you can directly eliminate three options in which your VB minus VA will be the correct answer. Okay, now By another one, by performing a set of experiments, a scientist found that the electric field between the 2 points A and B is zero. What can he conclude regarding the 2 points? So the electric field between the points A and B is zero. He can just conclude that then the potential will be what? Same only. So that is VA will be, that is the 2 points, the electric potential will be same only. So it is like, it's a direct questions they are asking. So they are not like, whatever the papers which I have analyzed for past previous year IMUCT questions, there is no like, they are you need to think too much for an answer. It is very basics plus above average, I could say. Okay, so everyone can crack the exam easily. Okay, now this is also a direct potential question, that is calculate the electric potential due to a point charge 10 coulomb at a distance of 8 centimeter away from the charge. You know that what is the electric potential at a distance r is q by 4 pi epsilon 0, or directly just substitute it. That's it. So through practice, they are this huge value of electric potential is not present. So just they have first. So this is another trick which I am telling. Once you get the question, just see what are the given variables. First check what are the given variables. So if I get a question like this, first I will see they have given a charge, that is 10 coulomb. They have given a distance r. Okay, so from there I can I can think where I can connect this point charge as well as the distance. So directly you will get that equation first. Okay, for the electric potential there is a connection between a charge and a distance, so your equation you can directly keep it in mind. So that's why I'm telling, you need to be thorough with all the equations, which is basic equation which is related to that particular topic. Okay, now okay, so I'll just give you one question. Can you guys please track it? A solid non-conducting sphere of radius 1 meter carries a total charge of 10 coulomb, which is uniformly distributed throughout the sphere. So determine the charge density of a sphere. Okay, so charge density of a sphere. So first thing you need to pick what is the variables. So radius they have given. So radius means something which is related to circle. Okay, so radius they have given, the total charge they have given 10 coulomb, as well as we need to find the charge density. So first thing, volume of the sphere. So this is again come in mathematics. So whenever you need to solve physics questions and all, please be thorough with little bit mathematics. So mathematics, in definitely mathematics you will study all this. So if physics and maths will be always parallelly going together. Okay, every time whenever you use the integration, differentiation and everything which you will be implementing in every physics problems. So be thorough with that, be thorough with basic mathematics, your mensuration and integration, differentiation and all basics you need. So so that also you keep it in mind. So here a solid non-conducting sphere of radius 1 meter carries a total charge of 10 coulomb, which is uniformly distributed throughout the sphere. Determine the charge density. Okay, so we know that volume of the sphere is what? 4 by 3 pi r cube, where r is the radius of the sphere, and thereby the charge density. So total charge divided by that particular volume will be your charge density at that point. Understand? So they have given the charge it as 10 coulomb, right? So 10 divided by 4 by 3 pi r cube, and r they have already given what is it? 1 meter. So you can solve it very easily. Understand? So your answer will be D. So there is another trick, as you can see, that in coming questions I'll explain. So first, so we discussed elimination method. Elimination method means whatever questions you are given, just check, just have a glance of about the answers which they have given. What all things you can eliminate first. So whatever, whenever you get a question paper, I mean telling the IMUCT question paper itself. So the first thing is that to solve the easy questions first. You don't go for any tough questions, and don't go for any easy whenever you see a tough question, you will stuck there. You will think about that theory and all, and then you will get in trouble. You will think about that. You will get tensed. Don't do that first. Have a glance of the question paper first. Try to solve the easy questions, and then you move
So,
to the tough
calculators allowed.
questions. Sorry,
Are calculators allowed?
what is Ratna?
Calculators.
Calculators, I think it is allowed. So don't worry. These and all are simple, calculations. So no need of calculator for this and all. Is it? You need calculator for this? All these are very, very simple
Well,
questions.
just that we're used to calculators more.
So you are used to calculate with
Yes,
used
in
to
state
calculators, huh?
syllabus we
Okay,
use
I
calculators
think
more.
it is allowed. For calculators in every JE key and all, it is allowed, right?
I don't think so.
You don't think so? I don't know. Let me check with that and I'll get back to you. Okay, for that.
Okay.
I'll just talk with the experts. Okay. Now, so the first topic is these are the basic equations you will cover in electrostatics. And for magnetostatics, that is, or magnetic effects of current. So basically, what is so these are the major equations. As you can see, Biot-Savart's law, that is G B equal to mu by 4 pi IDL into R by R cube. So if you want this means, I'll share the equations, everything. If you want to please have a, no, I'll give you my Gmail ID or something. I'll give you all the, culminated equations and the theories. Okay, so that you can take it as a pocket book. You can anytime you can just refer that one. Understand? Now, so Biot-Savart's law, dB is equal to, so this is related to, now here we have studied about electrostatic, now we are studying about magnetostatics or magnetic effects of the electric current. So first and major equation in magnetostatic as compared to Coulomb's law is Biot-Savart law, and dB equal to mu by 4 pi IDL cross R by R cube, where SI unit of magnetic, and this is also very important. So in some questions, as you can see that in some they will ask something about magnetostatics in which they will give the wrong units. So like that you can eliminate the other answers also. If they have given in something which is related to magnetostatic, they are not giving Tesla or any kind of Henry kind of thing means, you can directly eliminate that answer. That is one trick you can use. Okay, so Biot-Savart's law, and magnetic field intensity due to a straight current carrying wire, B equal to mu 0 I by 4 pi I sine theta 1 plus sine theta 2. Don't think about derivations and all, just mug up the equation. That's all the thing I can say. So magnetic field intensity due to semi-infinite wire, B equal to mu 0 I by 4 pi R. Magnetic field intensity due to infinite wire, B is equal to mu 0 2 pi R. Then solenoid, you can see B equal to mu 0 N I by 2 sine theta 1 plus theta 2. Then magnetic field for the center of current carrying loop, mu 0 I by 2 R. Center of the current carrying in circular loop, mu 0 I by 2 R alpha by 2 pi. Axis of the current carrying loop, B equal to mu 0 I by 2 R sine cube theta. Then for a wire, it is B equal to mu 0 I by 2 pi R, in which there are different cases where radius for the current carrying a long hollow cylinder, if the radius is less than, that is internal radius is less than external radius, B equal to 0, and for R greater than R, it is equal to B equal to mu 0 I by 2 pi R for ampere circular. So all the laws which is related to, or the name which is related to scientist, it is important. Okay, so like Coulomb's law, Biot-Savart's law, now it is Ampere circuit's law. So these all the laws which named after the each scientist, that is also very important, because they will shoot that question. That are the major or the basic equations which is related to that particular topic. So that you should be very thorough. Okay, so Ampere circuital law, it is integral of P dot dl equal to mu 0 summation of your current. Okay, magnetic effects of current, magnetic field lines that actually we started like in electric field lines. The same way you can see that magnetic field lines which start from north pole to south pole. Magnetic force on a moving charge particle, Fm equal to Q into V cross B. Motion of a particle in plane perpendicular to B cap is F equal to QVB, which is equal to mv square, is nothing but your centripetal force. Radius of circular path, V is not perpendicular to B, your helical path. R is equal to mv perpendicular by qb, that is mv sine theta by qb. Pitch of helix T equal to 2 pi m by qb. Hall effect, another one. So in this culminating, which I will tell, the most important equations is Biot-Savart's law, Ampere circuit law, and Hall effect. They will definitely shoot a question from this topic. It will be very easy questions only, so don't worry about that one. But all the which I already told now, like there will be some scientist name law, so they will definitely take that as one of your major questions. Okay, Hall effect, that is delta VH is equal to VD into BD. Okay, so these are like another motion of the charged particle, Lorentz force important, and magnetic force on the charge carrying current were kept in a field df, magnetic force between current. So F by L is equal to mu naught I1 I2. So these are the equations which I like a pocket equations that every time, anytime, if anyone asks, you should be thorough with these equations. So you can shoot, trust me, you can definitely crack physics question easily just by studying all the equations and basic theories. Okay, now, so some of the questions which I found out in your previous question papers: in a certain arrangement, a proton does not get deflected while moving through a magnetic field region. Under what condition it is possible? So magnetic force of a proton Fm equal to QVB sine theta, which is a major and basic equation. So a proton moving parallel or anti-parallel to a magnetic field does not experience any force. Hence, the proton does not get deflected while moving through a magnetic field region. So magnetic force on a proton Fm is equal to QVB sine theta, which is a major in basic equation. So what they have asked: in a certain arrangement, a proton does not get deflected while moving through a magnetic field region. Under what condition it is possible? So here they have given, if the magnetic field, so if the proton moving in a parallel as well as an anti-parallel to a magnetic field, it does not experience a force. Hence, if magnetic field is not activated, there is no moving of proton like either in both directions. So if the magnetic field F is 0, your protons will not get deflected through that particular magnetic field region. Okay, so your answer will be 0. Now, a wire placed along north-south direction carries a current of 8 ampere from south to north. Find the magnetic field due to 1 centimeter piece of wire at a point 200 centimeter northeast from the piece. Okay, so the basic equation. So what I told, whenever you get a question, first check the variables what they have provided for us. So here what they have provided, one is 8 ampere, that is current. Current is 8 ampere, which is from south to north. Then the magnetic field due to 1 centimeter piece of a wire, that is the length of the wire they have given is 1 centimeter. Right, at a point, and 200 centimeter north from each piece. So they have given what is the length of a wire at a point 1 centimeter as well as 200 centimeters. So your basic equation which we have already explained is dB equal to mu I dl sine theta by 4 pi r square. Just directly substitute the equation. So 4 pi into 10 to the power minus 7, mu 0, the value of mu naught is 4 pi into 10 to the power minus 7 into 8. 8 is nothing but that is the current into 1 into 10 to the power minus 2, that is the length of the wire. 1 into 10 to the power into sine 45, which they have not given in this question, I think they should provide the angle also. Okay, and 4 pi r square. R square is nothing but 2 square, that is nothing but your radius. Okay, so this is also a direct equation from the like which I have taken from one of their IMUCT question. A direct equation, you need to substitute the variables. Another question. A solenoid. So a solenoid of the solenoid means the word itself you have got it. So just you need to be thorough with what is the equation for the solenoid. B equal to mu naught Ni by 2 sine theta 1 plus theta 2. So a solenoid of 0.5 meter length with 100 turns carries a current of 5 ampere. A coil of 20 turns and of radius 0.02 meter carries a current of 0.6 ampere. So what you have understood from here? So there are two solenoids they have given. So one solenoid is of length 0.5, another solenoid having a length of 0.02 carries a current of 6 ampere as well as 5 ampere. They have given the turns also, there is 2 turns, 100 turns as well as your 20 turns. So explanation, so mu equal to 4 into 3.5, that so the number of turns in the solenoid is 100. The first current passing through the solenoid is 5 ampere. So number of turns of the coil is 20 and radius of the coil is nothing but 0.02. So they have given a solenoid in which they have given the measurement of the coil also. So solenoid, they have given two measurements, like two variables. One is the length and dimension of a solenoid, and another one is the dimension of the coil, which is turned, have a coil. So solenoid is what? You will have a conductor or a metal rod in which the coil will be sequentially circulated above that particular conductor. That is a solenoid. So in the question, what they have given is the whole dimension of the particular solenoid as well as the length and the measurement of the coil also. Okay, so here, so the first thing, you will grab all the variables. What are the variables which they have provided? They just asked what is the value of the torque required to hold the coil with its axis at right angle to the solenoid in the middle point of it. They are asking the value of the torque. Torque is nothing but, what is the basic equation for the torque? Anyone?
MB sine theta.
Sorry?
MB sine theta.
MV sine theta. Okay, so torque is, no, the torque is basically what you call, it is like, a force with having a distance. So whatever the force you are applied, if there is a movement for that particular, if there is any movement for that particular system, it is known as a torque. That means force into basically a distance, or work into distance is nothing but a torque. Okay, so solenoid is nothing but, so they have given mu equal to 4 into 3.14 into 10 to the power minus 7. The number of the turns of the solenoid, the first variable is number of turns in the solenoid is 100. So the current passing through the solenoid, first another variable 5 ampere. Number of the coil is 20, that is number of the turns in that particular coil is 20. Current passing through the coil is 0.6 ampere. Length of the solenoid is 0.5 meter, and radius of the coil is 0.02. So the magnetic field of the solenoid B equal to mu 0 by Ni, where mu 0 into 100 into 5, and this is equal to the equation. So directly you will substitute the equation, and magnetic field of the coil M is nothing but current into A into N, that's area into N, which is equal to 0.6 into 0.02 whole square into 20. And torque is MB sine theta. Theta they have given, they have represented as a right angle. So you have to take it as 90 degree. The torque will be 0.06. You have find out what is M and what is B. Just substitute it. Okay, sine 90 is nothing but 1. So your torque will be 1.893 into Newton meter, which means Newton meter, what I told is force into distance. Your unit will be force into distance for the torque. Okay. Now, a long straight wire of radius X carries a steady current I. The current is uniformly distributed across its cross section. Calculate the ratio of the magnetic field at x by 4 and 8x. So again we have the same equation. So the magnetic field due to a long straight wire x carrying at a point distance r is given by B is equal to mu 0 I r by 2 pi r square as well as x square. And B in another one is there are two cases where r less than x, where r greater than x, that is radius x less than x as well as radius greater than x. Okay, so the magnetic field at a distance of r is nothing but x by 4. They have given two distances, that is x by 4 as well as, and so your first equation will become what? Instead of x you will write it as x by 4, and the magnetic field at a distance of r equal to 8x, that is another distance. So instead of r you will write 8x. You need to divide these two, find out the ratio, you will get an answer as a 2. Okay, so these all things are, so by analyzing all these questions, do you find any difficulties to solve this? So unless and until you know all the equations, you have what do you call, there is nothing to worry about to calculate the equations or problem solving. It is very easy, like once if you know all the theories, as well as again I'm emphasizing this, means it is, that is how the IMUCET exam they have providing. Whatever the questions which I have analyzed, it is very straightforward questions. So any above average students or below average student can easily tackle it. Okay, so just be thorough with the equations. Now where did I stop? Okay, so this one, can you just find out, anyone please calculate two concentric coils of 20 turns each are situated in the same place. So the radii are 60 centimeter and 80 centimeters. Very easy equations. They have given 20 turns, 2 radius, 2 currents. So since two coils are concentric in the same plane, so your B will be B1 minus B2. So there will be two magnetic field. You need to just find the difference of that magnetic field. That's it. So here itself you can see that it is the calculations and everyone is this, and I don't think there is a need of a calculator here. You just can calculate by yourself. Okay, so these are just basic topics which, so Biot-Savart's law, Ampere's Hall effect, and Lorentz force. So these kind of equations you need to be thorough. Now let's move on to electromagnetic induction. So in electromagnetic induction, so again the basic equations which I have given the dimension. So for the dimension, so another way to tackle a question which I will say is to find the unit. So once check the options first. Just say, suppose if I wanted to get what is the magnetic flux of that particular system or whatever it is. So first I need to check the answer, in which they have given one answer's unit as Weber. If they have given it as Newton meter square or just Newtonal, you can directly easily eliminate it, because magnetic flux is nothing related to Newton. So just eliminating the unit also, you need to analyze whether they have given the correct unit also. Suppose if they are giving Weber or volt or Henry, so suppose if I wanted to find out what is the induced EMF in a particular coil, they need to be represented, the answer is in volt itself, or self-inductance, it should be in Henry, otherwise your answer is wrong. So like that you need to eliminate that also. If the one question consists of 3 options with Henry and 1 options with Newton, you can easily eliminate Newton. Then you need to think about the other options only. Okay, so these are the electromagnetic induction basic equations which comes under electromagnetic induction. What is a magnetic flux? Magnetic flux is nothing but integral of B dot dA, and this SI unit is Weber. Induced EMF is, or Tesla meter square. Okay, or induced EMF is nothing but epsilon is equal to minus d phi by dt. induced current is equal to minus epsilon by r or minus n by r d phi by dt. Induced charge is equal to I delta t, which is equal to minus n by r delta phi. So the motional EMF induced in a straight conductor, the linear motion is BLB. So for all this, you can see all this, your SI unit is volt. So rotational about 1 and bi omega by 2, everything for all this, it is for the induced EMF. Wherever you see, the unit should be volt itself. Then self-inductance, L equal to phi by R, L equal to epsilon E by di by dt. Self-inductance of a long solenoid, L equal to mu R mu naught n square AL. The unit is Henry. Mutual inductance, the unit is Henry. So mutual inductance means there will be two systems you will be giving. You need to see what is the inductance of that particular system. Okay, M12 equal to phi 2 by I1, M12 is epsilon E2 by di1 by d2. Mutual inductance of two long coaxial solenoids, M12 equal to mu naught M1 N2 M pi r square I, M12 equal to root of, that is cube root of Li by L2. Your SI unit is Henry. Now, magnetostatic energy stored, U is equal to half Li square. Alternating current and voltage E equal to E naught sine of omega t plus phi, and I is equal to I naught sine omega t plus phi. I RMS, root means square current, I equal to I naught by root 2. Okay, so phase relationship is nothing but for R, that is LCR circuit. This is basically a LCR circuit in which your resistance, inductance and capacitor is connected in series and it is connected in alternating current. So for R, you can see there is no phase difference between V and I. Suppose you are giving an input signal that is of one phase, your output will be of the same phase itself. There won't be any kind of, or if you connect a resistor to a particular AC circuit, the input signal in one phase, whatever the input signal's phase, will be your output signal's phase itself. For an inductance, if you are connecting an inductance to an AC circuit or AC supply, so your voltage and current, the phase difference, as you can see that it is will be 180 degree. Okay, now for capacitance, you can see that the voltage, again there will be a phase difference, and in which you can see that the voltage leads the current by pi by 2, that is they will be out of phase, in which voltage leads the current by pi by 2, and for C the current leads, that is for capacitance, the current leads the voltage by pi by 2. As you can see, the angle phi is equal to tan inverse XL by XC by R, where XL and XC is nothing but the impedance, or tan phi is equal to tan inverse VL by VC by R. So this is a unitless dimensional. So this is an LCR circuit or phase relationship of an LCR circuit in which both all the three will be connected in series manner, not in parallel. Okay. Now see the equation, see the question, find out the correlation from the following. Just you need to be thorough with the units. Explanation is 1 Weber is nothing but 1 Tesla into 1 meter square. So Weber is nothing but 10 to the power goes into 10 to the power centimeter square. So 1 Weber is 10 to the power Maxwell. Very easy equation. Very easy question. Now, the magnetic flux in a closed circuit of resistance 20 ohm varies with time t as phi is equal to 4t cube plus 2t square minus 15t plus 3. Calculate the magnitude of induced EMF. Induced EMF at t equal to 1 second. So first thing, induced EMF you got it. You need to find out the induced EMF. Check whether all options they are having the same unit. So in this one all are having same unit, which is like, you cannot eliminate any unit. Suppose I have like 6 Newton here for the D option. If they are giving like 6 Newton, you can directly eliminate that option then and there itself. You can only see or only check whether the other three options are correct or not. Okay, blindly you can remove it. Now answer, like, so the given resistance, so what are the variables? So whenever you get a question, check the variables first. So once you read the question, what are the variables we have given? Resistance 20 ohm, resistance 20 ohm. Phi, what is it? As a function of t, they have given phi equal to 4t³ plus 2t square minus 15t plus 3. Now the required equation, induced EMF epsilon equal to minus d phi by dt, E is equal to d by d phi. Phi, direct equation, just differentiate this equation. That's it. Just differentiate that equation. That is 4t square plus 4t³ plus 2t square minus 15t. You will get an equation. Just substitute it. Since t equal to 1 second, E equal to what is the induced EMF at 1 second. Just substitute t equal to 1. You will get an answer 4 volt. That's it. Very easy, very straightforward question. Now, so a bar of length 0.7 meter slides along a metal rail at a speed of 1 meter per second. The bar and the rails are in magnetic field of 20 Tesla pointing out into the page. Calculate the motional EMF. Again, they have given EMF. Check the equation whether they have given the same unit. Yes, they have given the same unit. Now check for the variables. What are the variables they have given? Length is equal to 0.7 meter. Speed is equal to 1 meter per second. Magnetic field B is equal to 20 Tesla. So the required equation, just connect VLB. So emotional EMF E is equal to minus VLB. Okay. They have given the negative sign only applies to the direction. Directly you should substitute the variables what they have provided. That's it. You got the answer. That is equal to 1.1. A bar of length 0.15 meter slides along metal rails at a speed of 5 meter per second. The bar and the rail are in the magnetic field of 40 Tesla pointing out into the page. So the resistance of the two resistor parallel is both 20 ohm and the resistance of the bar is 5 ohm. What is the current in the bar? So they have given a bar of length 0.15 meter along with the metal rail speeds of 5 meter per second. Okay, the bar and the rails are in a magnetic field 40 Tesla pointing out into the sorry for the interruption, sorry. So a bar of length 0.15 meter slides along with the metal rails at a speed of 5 meter per second. So again we are going to check the variables. Okay, we will check the variables what they have given. One is L, that is equal to 0.15 meter. One is B, that is 40 Tesla. Then again they have given speed, that is 5 meter per second. Then what they have given is resistance of these two bars, that is one resistor is R, that is 10 ohm, R2 is again 10 ohm, then R3 is 5 ohm. So we have one equation, that is EMF E is equal to V into L into B. So directly you can find out what is the equation. Now R1 and R2 are in parallel. What they are asking, what is the current in the bar? So R1 and R2 are in parallel. What is the equation for resistance in parallel? Resistance in series and parallel, anyone? Resistance in series and parallel. Okay, so resistance in series, the total resistance will be R1 plus R2 plus R3, and for parallel it will be 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3, like that. Okay, so here they have given two resistance, that is your resistance 1 and resistance 2, that is 1 by 120, 1 by 20 as well as 1 by 5. So your total resistance will be 10 ohm. So resistance total will be known as 15 ohm. Therefore, the current will be what? Your induced EMF into resistance. So your current will be 2 ampere. Options will be 2 ampere. That is option. Now, calculate the mutual inductance between two coils if a current 10 ampere in primary coil changes the flux by 500 Weber per turn in the secondary coil of 1200 turns. Okay. This is also one straight equation. Your basic equation is what? N phi equal to mutual inductance is nothing but mutual induction equal to phi into N. They have given, that is mutual inductance into I, that is 200 into 500. They have given 200, that is a secondary coil, turns in the secondary coil, into what is phi, that is a magnetic flux, 500 Weber equal to mutual inductance into your current, that is 10 ampere. So M equals to 10 to the power 4 Henry. Okay. So again you can check the unit which they have given. They have given the same unit. So like 4 options you need to consider. Okay. So these are the basic equation for the electromagnetic induction side. So we have discussed 3 topics: electrostatics, magnetostatics, as well as electromagnetic induction. Okay. Now we will go for nuclear physics. So in nuclear physics also, like I don't think, like whatever the questions which I have analyzed, I did not find any problem solving questions. They are asking direct theory questions instead of problems. Whatever the previous questions which I have analyzed, there won't be any kind of so basic nuclear physics theories you should be aware. Okay. So radius of the nucleus, we know that R equal to R naught A to the power 1 by 3. Density of the nucleus, mass by volume, that is mass of one nucleon into A divided by 4 by 3 pi R cube. Nuclear force theory. Nuclear force is a force which holds the nucleons together. The graph is important. Once again, I will tell about the graph. All the graph, the basic, basic trick to remember the graph is that you just remember what is an x-axis and what is an y-axis. So that whatever if I'm asking about voltage or resistance and all, what will be in x-axis, what will be in y-axis, the first thing you should be aware of, or you should be thorough about. Okay, so nucleons force bind together on the stability graph of this nuclear force, in which your neutron as well as protons. The protons will be in your x-axis and neutrons will be in your y-axis. Okay, so mass defect, the difference between the mass of constituent nucleons and the nucleus is called as mass defect of nucleus. So all the theories, what is mass defect, what is binding energy, what is nuclear fission, what is nuclear fusion, everything you need to clearly thorough about. Okay. So what is binding energy of nucleus? Binding energy of nucleus is the energy released when constituent nucleon are brought from infinity to some nucleus. The same way, what is it? Binding energy. Same way in electric field intensity, you will take one positive unit charge from infinity to that particular electric field intensity. So same way, that is a binding energy. Okay, so theories and all will be little bit somewhat confusing, but you need to be thorough with all these. Okay, so representation of an atom. A is nothing but your mass number, Z is nothing but your atomic number. What is one atomic unit? 931.5 mega electron. Okay. Mass defect equation, B equal to delta MC square. So these are the very basic major equations. So let's go for the problems. So the magnetic moment of a revolving electron around the nucleus varies with the principal quantum numbers of the which following number. The explanation of the principal quantum number L is equal to NH2 pi and mu is equal to EL2. These are the equation for quantum number, principal quantum. Mu is nothing but the magnetic moment. The magnetic moment and the relation between the principal quantum number is mu is equal to EL2m. So just find out, just equate this one and or substitute L in here. So you will find out what is the value of mu and find out what is the relationship between the principal quantum number as well as your magnetic moment. Okay. Same way. So for uranium nucleus, how does its mass vary with the volume? So mass of the nucleus is nothing but nuclear density into volume. So the nuclear density of an atom is constant, that is 10 to the power minus 17 kilograms per meter cube for all nuclei. Therefore, the mass of the nucleus is directly proportional to the volume. That is answer A. Any nucleus, the mass of any nucleus is directly proportional towards volume. Next one, a nucleus at rest splits into two nuclear parts having radii in the ratio of 1:3. Find out the ratio of their velocities. So R is known as R. We have already known the general equation. Radius R equal to R naught A1 or A to the power 1/3, and here they have given two nuclear parts, so they have taken two radiuses, R1 equal to R naught A1 to the power 1/3, R2 equal to R naught A to the power 1/3. Okay, so R1 by R2, that is you need to divide R1 by R2, you will get 1/27. So the ratio of their masses is given by M1 by M2, that is 1/27. So according to conservation of momentum, that is conservation means that whatever the system or whatever the position or whatever the variables in the system before a change should be equal to the after a change. So here conservation of momentum, the magnitude of P1 should be equal to magnitude of P2, that is M1 V1 is equal to M2 V2, that is V1 by V2 is equal to M2 by M1. So here already we got that M1 by M2 is 1/27. So M2 by M1 will be 27 is to 1. The ratio will be 27 is to 1. What is the energy released in the fission of 2 kg of uranium-235? So energy release, so energy per fission is 200 mega electron volts, which they have already given. For uranium-235, the number of atoms in 235 grams is 6.023 into 10 to the power 23. That is Avogadro number. So the number of atoms in 2 kilograms will be 2 into 6.203 into 10 to the power 23. So the number of atoms will be N equal to 5.1. Therefore, the energy released in the fission of 2 kg of uranium-235 will be E equal to 200 mega electron volts into N into 1.6 into 10 to the power minus 19. That's the charge of your total calculated value will be equal to 1. So I will just discuss about the major equations and nature of radiation and matter as well as semiconductors in time is limiting. So dual nature of radiation and atomic physics. So these are the equation, that is E equal to h nu, where h is nothing but your Planck's constant and mu is frequency hc by lambda. Then work function W naught is equal to h nu naught, which is equal to hc by lambda naught. K max, that kinetic energy max will be half mv square, where K max equal to h nu minus mu naught. Then lambda is wavelength is h by mv, that is mass into velocity, nothing but your momentum. And another equation for lambda is equal to h by 2 root of 2 me, where E is your kinetic energy, V is your accelerating potential, lambda is equal to h by root of 2 mev, another equation where V is your accelerating potential. So major equations. And another topic which we have going for the semiconductors. So just study about classification of materials on the basis of energy bands, the energy gap, the energy gap value in metals. In metals it will be that, which will be, so basic how you can classify metals, insulator and semiconductors. So they will have two conduction bands, that is energy bands. One is conduction band and valence band. So once you give a threshold energy in the valence band, one electron will be excited to the conduction band. So in metals you can see there is no gap between valence band as well as the conduction band. In insulators the gap between the valence band as well as the conduction band will be very high. It is, e.g. is they have given greater than 3 electron volts. And for semiconductors, the size or the energy gap will be in between metals as well as in insulators. So semiconductors means it is by itself it is conducting. So if you give a threshold energy which is less than 3 electron volt, it can act as a conductor. Okay, so two types of semiconductors: intrinsic and extrinsic, p-type and n-type, and barrier height, reverse bias, dynamic resistance and all. Please try to study all the equations related to this. So as time is approaching by 12:30, if you have any if you have any queries, please mail me. I can provide you all the materials, equations and everything, like a pocket equation, so that you can refer easily. So I hope that I'll see you soon here, everyone. Let me wind off.
Yeah, madam, is it audible?
Yes, sir. Yes, sir.
Yeah, thank you very much, madam. Your session is very nice.
Thank you. Thank you, sir.
Yeah, thank you, madam. Students, you can wind up now. Thanks a lot.
Thank you. Thank you, sir.
Thank you, teacher.
Thank you, ma'am. Thank you. All the best. Write well. Join well soon. Score nice and then come back. Done.
Thank you, madam. You can wind up now. Thank you.
Thank you.
தெரியும். நமக்கு மீன் கிடைக்க மாட்டேங்குதுல்ல, காய் தானே மீன் காய் தான் காய். அது மீன் இல்ல